Let's do one last problem, one more synthesis problem. In this problem, we will again start with benzene. And then the product has a fluorine in it. So say we want a fluorine there, and then we want this acyl group at this position. So one thing we might notice if we start from the product side, let's go ahead and try to do a retrosynthetic analysis. So pause the video and try that before you actually start providing any reactions and conditions for the forward synthesis. Let's do a retrosynthetic analysis of this material. Looking at this, what might draw our attention is the presence of a fluorine, and we really only know one way of installing a fluorine on a benzene ring, and that is diazonium salt chemistry. So perhaps a good beginning of a retrosynthetic analysis would be to say that this product would have come from the corresponding diazonium salt. So that's just NN there. And then the question would be, well, where do diazonium salts come from? The diazonium salts come from the corresponding aniline derivatives, that is an NH2 group here. So if only we could get our hands on this aniline derivative, we could convert the NH2 group into the diazonium salt. And then where do anilines come from? An aniline can come from reduction of a nitro group. So if we had an NO2 group here, a nitro group, perhaps we could convert this along this path to the desired product. And then here we have a nitro and an acyl group meta to each other on the six-membered ring. Now both acyl groups and nitro groups are meta-directing, so one might naively think that it doesn't matter what order we introduce those groups in. But remember that Friedel-Crafts acylation and Friedel-Crafts alkylation reactions don't work on a benzene ring that's any more deactivated than a monoaryl halide, okay? And so if you tried to first nitrate and then do the Friedel-Crafts reaction, that would fail. So you want to instead do the Friedel-Crafts reaction first instead of second. So we would want to nitrate this compound, and this compound can come from benzene itself. So this is one possible retrosynthetic analysis for this problem. So if you want to work on what are the exact reagents that you would need to carry this out, please do so at this point. So starting from benzene and coming over here, this is a Friedel-Crafts acylation reaction. So we would need an acyl chloride and aluminum trichloride. And then from here to here, this is a nitration. So the conditions for nitration, remember, are nitric acid and sulfuric acid. So that will put a nitro group in. Notice, since we already have the acyl group, and the acyl group is a meta-directing group, we should get the desired 1-3 relationship between the two groups. Now we have to reduce the nitro group to the NH2 group, and this can be done just using palladium on carbon as our catalyst and hydrogen as the reducing agent. And then to convert the NH2 group into the corresponding diazonium salt, Remember, this requires sodium nitrite and acid. And then finally, the final reaction where we replace this excellent leaving group. The leaving group is just molecular nitrogen, N2. We replace that leaving group with F. One can do that using this acid. So this would be the final pathway. We started out with the retrosynthetic analysis, and then we provided all of the conditions necessary for the forward direction, and that completes the synthesis of this di-substituted benzene starting from benzene itself.